Hello again, it's Jason from STEMonline.com, where we offer online mathematics and physics tutoring for senior high school and university and college students. Okay, so today we're going to discuss something about demystifying the derivative from first principles to shortcuts. Okay, so the question we're going to look at specifically, okay, and that question is the following, okay? Why does the derivative, so why does the derivative, right, so why does the derivative, let me make some room here, we're gonna need a lot of room for this problem. So, question, why does the derivative, why does the definition of the derivative f of x plus h minus f of x all over h matter when we already have the power rule and chain rule. The power rule and chain rule. Okay, so the reason for this is because for one thing, we can derive interesting results on derivatives on the power rule and chain rule. So what we're going to do is we're going to prove that, okay, we're going to prove from first principles, first principles, that d by dx okay, so in a second, d by dx of x to the n is equal to nx to the n minus 1, where n has to be greater than 1. Okay. All right, so what we're going to do for this, right, is we need to use the following. Okay, we're going to use the following definition, that the derivative, right, so dy dx, okay, so dy dx is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so we're going to use this. All right, on our function that we're dealing with here. Okay, so the function that we're dealing with is x to the n. Okay, so on the side here, right? So on the side, we know that f of x equals x to the n. Okay, we want to figure out what f of x plus h is. So f of x plus h. So x plus h gets substituted for x. This becomes x plus h all to the n. There is x plus h all to the n. Okay. All right. So, but this can be extrapolated more. X plus h to the n, if you look at this carefully, this is some sort of binomial, if you look carefully here. Okay. So, we know that x plus h all to the n, right, is equal to the sum, okay, from k equals 0, first index of the sum from k equals 0 to n, right, of n choose k of x to the n minus k times h to the k, okay? So we're using the binomial theorem here, okay? This is the binomial theorem. Okay, so that's our justification for the substitution. So let's substitute this information into our first principles derivative formula. So this will become limit as h goes to 0, f of x plus h. That's just x plus h. First we put in x plus h all to the n minus x to the n. Okay, this is x to the n. X to the n. Make my h better. This is h. And this is all divided by h. Okay. All right. And since we know that x plus h all to the n is the binomial theorem, okay, so this becomes limit as h goes to 0, x plus h all to the n. That becomes the summation from k equal 0 to n, okay, of n choose k, okay, of x to the n minus k times h to the k times h to the k minus x to the n, okay, all over h. Okay. Then from here, you're going to notice something else. Well, we can extrapolate this binomial theorem. Right now it's compacted as a summation. Since we know that summations, right, always start at the starting index and then we increment by 1, okay? So we're going to increment by k equals 0 for the first part of the expression of summation, k equals 1, k equals 2, k equals 3, all the way up to k equals n. Okay, so let's do that. So this now becomes n choose 0, n stays constant, k is changing in the summation, n choose 0, times x to the n minus 0, okay, times h to the 0, because k is 0, all right? And then we're going to do plus n choose 1 times x to the n minus 1 times h to the 1, okay, because k is 1, plus n choose 2, parentheses, x to the n minus 2 times h squared, because k is 2 now, plus dot, dot, dot. It has to be dot, 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 because we have n indexes, like k indexes from 0 to n, and we have to sum up them. Okay, so it's plus dot, 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 n choose n, x2 times x to the n minus n times h to the n, because n is k now. Okay, put this all in parentheses, right? All in parentheses. And then multiply by h to the k, right? Because if you multiply by h to the k, that's all in the thing of the binomial, of this binomial expansion here, okay? Because h to the k was here. Then minus x to the n, right? Minus x to the n, all divided by h, okay? All divided by h. All divided by h. Okay, so now we have this expression. We're not done yet because we have to figure out what these combinations are. By the way, these are combinations. If you're familiar with the formula that n factorial, right? Right, so n choose k is equivalent to saying n factorial divided by n minus k, all in parentheses, times factorial times k factorial, right? Where n is the number, and n is always greater or equal to k. It has to be greater or equal to k, otherwise you get negative factorials. It's not allowed. Okay. All right, so n. So we're just, that's what this represents. Okay, from combinations. Okay, so we have this. Then we're going to extrapolate more. Okay, so this is now going to be the limit. Limit as h goes to 0. N choose 0. Let's see what that gives us. Okay, so parentheses, n choose 0 is going to be n factorial. Right, it's going to be n factorial. Here, n factorial, all over n minus 0, all factorial. Okay, this k is 0 here. Then 0 factorial, right? Times x to the n, k is 0. H to the 0 is 1, so we have plus n factorial. Okay, so n factorial all over n minus 1 factorial times 1 factorial times x to the n minus 1. Okay, times h, right? H stays there because k was 1, plus n factorial all over n minus 2 factorial times 2 factorial, okay, times 2 factorial times x to the n minus 2 times h squared, plus dot 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 dot. N choose n. Well, let's see what that gives us. That'll be n factorial all over the n minus n factorial. Okay, n minus n factorial, all factorial times n factorial. Okay, x to the n minus n, that's x to the 0. Well, x to the 0 is 1 times h to the n, all in parentheses, times all in parentheses times h k. So h to the k is multiplied by that binomial expansion minus x to the n. Okay, all divided by h. Okay, so divide everything by h. Okay, as you can see, this derivation is very long, so you have limit as h goes to 0. This is gone, this is gone. I'm left with n factorial over n factorial x to the n, right? Plus n factorial all over n minus 1 factorial. Factorial is 1 times x to the n minus 1 times h plus n factorial divided by n minus 2 factorial times 2 factorial times x to the n minus 2, x to the n minus 2 times h squared, plus dot 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 n factorial over n minus n, 0 factorial times n factorial, times x to the 0, x to the 0 is 1, this becomes h to the n. All this is in brackets because I'm going to be multiplying by, what's it called? Yeah, I almost forgot this guy, h to the k, minus x to the n, all over h, okay, all over h. Looks like we're running out of room. Okay, I'm gonna have to move to the side here. H. What you'll notice here, this disappears. I'm left with, well, doesn't exactly disappear. N factorial. N factorial is just n. Okay, so this is equivalent to so this is going to be a limit. This is going to be equivalent to the limit equivalent to the limit as h goes to 0. This goes to 0 of x to the n times n factorial over n factorial. Let me see here. 0. Yeah, it's going to be n factorial. It's going to be limit n. Yeah, it's going to be n factorial. Right? It's going to be n factorial. Okay, n factorial divided by n factorial divided by n factorial. Okay, n factorial. N factorial divided by n factorial. Okay, so we've gotten rid of the factorials here because it's been divided out. Okay, so the factorials are gone. Times x to the n. Okay, x to the n. Actually, I don't really need to write this. This is gone. Okay, so let's see. Yeah, well, n factorial will just be n times n. Yeah, this will just be n. N times n minus 1. Yeah, n times n minus 1. That gets cancelled. Yeah. So that's just x to the n. Yeah, that's fine. That's what I had before. It's fine. X to the n here. Yeah, x to the n. Okay. And then we have, so what's going to happen here is we're going to have x to the n. Okay. X to the n plus n factorial. Plus n factorial all over. N factorial all over n minus 1 factorial. N minus 1 factorial. Okay. Times x to the n minus 1 times h plus n factorial all over n minus 2 factorial. Yeah, this is an n factorial of n minus 2 factorial times 2 factorial. Okay, times 2 factorial times x to the n minus 2. N minus 2 times h squared. That's an h squared. And h squared plus dot plus n factorial of n factorial, that cancels, or factorial is 1, h to the n plus h to the n. This is all multiplied by h to the k minus x to the n, and I'm going to divide the whole thing by h. Okay, so divide the whole thing by h. X to the n cancels, I'm left with just this portion. Okay. You'll notice an h can be factored out from everywhere there. The h will cancel. I'm left with just the n factorial. This is n times n minus 1, and I'm left with n times n minus 1 times x to the n minus 1. Okay, so n times x to the n minus 1. And that is equal to our d by dx of x to the n. Okay. Alright, that is it. If you enjoyed this video, subscribe for more videos on math and physics. You can, just subscribe to the YouTube channel. And if you're still having trouble understanding calculus, especially when it comes to derivatives or anything else in calculus, you can contact us at www.stemoneonline.com. Okay, have a good night. Bye-bye.